ELK-EFK stack, centralized logging and observability. Agenda, log management approaches, ELK-EFK history. Why ELK-EFK? Log pipeline lifecycle, getting started, basic workflow, indexing and querying. Log management, every running application and server produces logs, text records of what happened and when, that engineers rely on to understand system behavior. If something breaks, the difference between a 5-minute investigation and a 5-hour one often comes down to how easy those logs are to search. Almost every team running more than a handful of servers eventually needs a way to search logs from all of them in one place. Any team debugging a distributed system benefits from correlating logs across many services at once. SSHing into servers one by one to grab log files doesn't scale. Local and centralized logging. Local logging keeps each server or container's logs on its own disk, accessible only by connecting to that machine directly. Centralized logging ships every log line to one searchable store, so any log from any service can be found in one place. Local SSH plus tail grep. Journal-CTL on one host, lost when a container dies. Centralized ELK-EFK stack, one searchable store, survives the source dying. Problems with decentralized logging. Single point of failure. Logs disappear the moment a container or disk is gone. No way to search across many machines at once without custom tooling. Correlating a single request path through multiple services means opening many separate log files. Slow incident response. Since finding the right server and log file eats into investigation time, every team invents its own ad hoc scripts for pulling and searching logs. Misses out on structured search, dashboards, and alerting built on top of the raw log data. The ELK-EFK stack system, Logstash or 20 collects, passes, and ships logs from applications and servers to a central store. Elasticsearch stores and indexes every log line, making full text search fast even across billions of documents. Kibana provides a web interface for searching, visualizing, and building dashboards on top of that indexed data. Other similar centralized logging systems, Grafana Loki, Splunk, Datadog log management. ELK-EFK advantages. Full text search finds any log line across every service in seconds, not hours. Dashboards turn raw logs into trends, counts, and visual patterns anyone on the team can read. Structured parsing extracts fields from messy log lines, making them filterable and aggregatable. Alerts can fire automatically the moment logs match a concerning pattern. Scales horizontally, adding nodes to handle more logs as the system grows. Backed by a large open source community and widely used across industries. Everything is indexed almost. One huge benefit is that in Elasticsearch, almost every field in every log line is indexed automatically, not just searched line by line. Full text search returns relevant results in milliseconds, even across enormous volumes of logs. Structured fields like a status code or a service name can be filtered and aggregated instantly. Time-based indices let old logs be archived or deleted without touching the data still in active use. This indexing is what turns a fire hose of text into something you can actually ask questions of. Logstash, Fluentd, and Elasticsearch. Logstash Fluentd passes and ships log lines into structured events. Elasticsearch indexes and stores those events for fast search. Logstash.conf configuration file. A Logstash pipeline reads log files, passes them, and ships the results to Elasticsearch. Elasticsearch query. A query, domain-specific language (DSL), request searches for error level logs from the last hour. History. Elasticsearch was created by Shai Bannon and released in 2010, built on top of the Apache Lucene search library. Logstash and Kibana joined soon after, and the three together became known as the ELK stack. Elastic, the company, was founded in 2012 to develop and support the stack commercially. Fluentd, developed separately by Treasure Data, became a popular Logstash alternative, giving rise to the EFK variant. Elastic later introduced bits, lightweight shippers, and renamed the broader platform the Elastic Stack. Why ELK EFK? Unified search, every log from every service searchable in one place. Fast. Elasticsearch indexing makes full text search practical at huge scale. Visual. Kibana turns raw logs into dashboards anyone on the team can read. Flexible ingestion. Logstash and Fluentd both support a huge range of log sources. Open source. Free to run yourself with a large ecosystem of plugins and integrations. Extensible. The same stack often expands to cover metrics and traces alongside logs. The Elasticsearch Index. An index is the fundamental unit Elasticsearch uses to organize and search documents. Logs are commonly split into time-based indices like app logs 2016 January 15, one per day. Index lifecycle management can automatically roll over, shrink, or delete old indices. Never index unbounded, unstructured data forever. Retention policies keep storage and cost under control. Log pipeline lifecycle. Log pipeline lifecycle. Fluentd logstash collect, send to Elasticsearch, ship, Elasticsearch index, Kibana dashboard visualize. Logs are collected at the source, shipped to Elasticsearch, indexed for fast search, and finally visualized through Kibana dashboards. Getting started with Elk Efk. This leads us to the three steps that get logs flowing and searchable. Deploy Elasticsearch. Stand up the search and storage backend. Configure logstash friendly. Point to log shipper at your application's logs. Explore in Kibana. Build searches, dashboards, and alerts. Basic workflow. Application log aggregation from say Kubernetes kind as daemon set, scraping the logs of APIs, microservices across nodes into the ELK EFK stack for visualization, comprehension, feedback, alerting, and optimization. Shipping, indexing, and querying. Some call ship, index, and query ELK EFK's everyday loop. New logs are shipped continuously, often within seconds of being written. Elasticsearch indexes new documents in near real time, making them searchable almost immediately. Kibana's saved searches and dashboards turn one-off investigations into reusable tools. Alerts can be layered on top of any saved query to catch problems automatically. Supports many workflows, incident response, security monitoring, application performance analysis. Works the same whether logs come from containers, servers, or serverless functions. Any questions? Thank you.